All right, video 4. We are on problem number 24. Yep. Which point lies on the graph of the inverse of the function shown? So inverses are the x and the y values have been swapped. So I'm going to look at this graph and I'm going to find points that are on it. So that point is over 1 up 2. This point is over 2 up 4. And it looks like right there, over 3 up 8. So the inverse then, 1, 2 becomes 2, 1. 2, 4 is 4, 2. 3, 8 is 8, 3. And then, of course, that one also, we could include that one, which I didn't. So that's over 0 up 1 becomes 1, 0. And that is our inverse. The inverse is always the mirror image across the line, this diagonal line. Y equals mx plus b. So that line is y equals 1x plus 0, just y equals x, slope of 1, y-intercept of 0. And so looking at these choices, oh, maybe I should have written them down. 1, 0, 2, 1, get my comma in there, 4, 2, and 8, 3. 2, 4 is not there. Negative 3, 1/8, nope. 8, 3, yes. 1, 2, no. So there you go. Find the inverse of the function. The f of x is the y, so we switch the x's and the y's. So the y becomes an x, and the x becomes a y. And then you switch, and then you solve for y. So to solve this for y, I'm going to plus 3 both sides. And now we're going to divide both sides by 2. So I can write it like that. And also, I'm just going to swap sides. And instead of writing y, I'm going to write f inverse of x. So I can write it x plus 3 all divided by 2, or I could write that x over 2 plus 3 halves. And then even still, instead of writing x over 2, that would be 1/2 x plus 3 halves. And that's our inverse. Find the inverse of this one. All right, swap the x and the y, and now we're going to solve for y. So I'm going to add 7 both sides. X plus 7 equals 2y squared, and I'm going to, at this point, I'm just going to flip sides, and now we're going to divide the 2. X plus 7 over 2. And then that's for y squared. So to solve for y, we take the square root of both sides. So the square root of x plus 7 over 2. And so this domain, x is greater than 0. So when we're solving for a variable and we take the square root of both sides, we normally would have to say plus or minus that. But since they're saying just make this positive, greater than or equal to 0 is positive, we're just going to answer with the positive one. And solving. So when you have a radical square root or any kind of root, you want to get the radical to be alone. So first I'm going to minus 8 both sides. So the square root of 3x plus 7 is equal to 5 minus 8 is 7. And now I want to get rid of that radical. So we're going to square both sides. The squaring undoes the root, leaving the radicand. The radicand is the name for the part under the radical. Leaving the radicand alone. And 7 squared is 49. And now we're going to minus 7 both sides. And then divide both sides by 3. 42 divided by 3 is 14. You'll also want to do a quick look at your equation, throw it back in, see if it makes sense, and it does equal, each side equal. So 42 plus 7 is 49. The square root of 49 is 7. 7 plus 8 is 15. So we're good on our answer. And here's another one. We want the radical to be alone. So I'm going to minus 1. Negative 3 times the square root of 5x minus 2 is equal to 9. And now we want to divide. That negative 3 is being multiplied by the radical. So we divide both sides by negative 3. Square root of 5x minus 2 equals negative 3. Something squared equals negative 3. Can't happen. Square roots have to be positive. So no solution. If you did go and solve it, square both sides, etc., when you go and plug it back in, it would turn out to be not true. And there's another one, but instead of written with a radical, it's got the fraction exponent. So we're going to raise both sides to the same power. And the power I choose is the reciprocal of 2/3, which would be 3/2. Because now when I go to simplify this, this is a power to another power. And so you would multiply your powers. And any number times its own reciprocal is equal to 1. So that is how those powers are canceling. So that leaves the x squared minus 4x plus 3. And now we've got to do what is 4 to the 3/2 power. So that means the square root of 4 cubed. The square root of 4 is 2. 2 cubed is 8. It's quadratic, so I want to get everything on one side. X squared minus 4x, 3 minus 8 is minus 5 equals 0. And now we can factor. Let's see, that would be a minus 5 and a plus 1. Outside is 1x minus 5x, giving us negative 4x. And last, negative 5 times 1 gives us negative 5. And so x minus 5 equals 0, and x plus 1 equals 0. Add 5 to both sides, x equals 5, and x is negative 1. And now I'm going to plug them each in to see if they both work. So plugging in a 5. 5 squared is 25 minus 20 plus 3. 5 plus 3 is 8. 8 to the 2/3 power. So that would be the cube root of 8 is 2. 2 squared is 4. And so it does equal 4. So I was just looking at before all my blue lettering on top, just the original equation. So the 5 works. Now let's see if negative 1 works. I'm gonna just erase that. -1 and -1 there. So -1 squared is 1. Minus 4 times -1 would be +4. And that's 5 plus 3, and that is 8. 8 to the 2/3 we already know gives us 4, and the right hand side is 4. So both of these are working. All right, 28. Which functions would produce the same graph as f of x equals 81 to the power of x? So this one, 9 squared is 81. So that one, this one would. 18 squared is not 81. 3 to the 4th power is 81. So this one gives the same. And 1/9 to the -2 is 9 over 1 to the +2, which is 81. So this one works as well. When evaluating the function for any real number, what must be true about the value of f of x? For any real number x, what must be true? Okay, so I'm going to think about the graph of this. So it's exponential, but the negative means it's reflected and down across the x-axis, and then the +5 is we're up 5. So our horizontal asymptote is y equals 5, and so a normal one would go, oops, I did not x growth. I did decay, but it's growth. So the normal one would be like that. So we're doing the mirror image. So it would look like that. So back to the question, for any real number x, what must be true about f of x, or the y? So if you're thinking about plugging in any x along this x-axis, our y values are on the graph, and they're always staying below the asymptote. Even on this left-hand side, it's going to keep getting closer and closer. It never crosses the asymptote. And on the right-hand side, it just keeps getting lower and lower and lower. So the value of f of x is always negative. That's not true, because our value of f of x from that section is positive. The value of f of x is always positive. Not true. This portion of it is negative. The value of f of x always greater than 5. Nope, less than 5. And I'm just going to check the time because I don't want to go over a certain amount. It's been 13 minutes, so I'll do one more. Ugh. So this is all calculator. You want to invest $3,600. The bank gives you 3 options. Choose which option would yield the highest return on your investment. So we're plugging in the principal as, what was it, 3,600. So for option A here, A would equal 3,600 times 1 plus, the rate is 2.6%, so that's 0.026, divided by n. N is the number of times it's compounded per year. This says compounded quarterly, so n is 4. To the power of n, which was 4, times t, it says 4 years. And so you just got to know how to put this in your calculator and to get the right answers. So make sure you're practicing with your calculator. This one is 3,993.22. So I rounded off to 2 decimals because we're talking about money. And so that would be appropriate for 2 decimal places. Option B, A is equal to, we still are investing 3,600. 1 plus, our rate went to 3.2%, moving the decimal twice to make it a decimal. Oops, 0.032 over compounded monthly, so n is 12, over 12 to the power of 12 times number of years is 3. And calculating that one, $3,962.23. And the final one, A is equal to, so it's compounded continuously, so that has a different formula. It's got the E in it. Remember, E just means 2 point something. It's a constant, like pi is a constant. So P is 3,600 times e to the power of r is 0.027 times t, time is 3 years. And again, you got to make sure you know how to do that in whatever calculator you're going to be using when you take the final. 3,903.74. And so I'm just looking for the one that has the biggest number. So 3,903, 3,962, that's bigger. 3,993 is the biggest. A is best. All right. Solve. So when we're solving and our variable is in the exponent, we have a couple of options. One option is to get the bases to be the same number. So can I represent 16 as 2 to some power? Yes, we can. 2 to the 4th power is 16. So I'm going to replace 16 with 2 to the 4th to the x plus 8. And now I'm going to simplify the right-hand side. Power to another power we would multiply. So 4x plus 32, you got to multiply it to the 4 to both of them. And so now that our bases are the same number, we can set the exponents equal to each other. I'm going to minus 4x both sides. That gives me a 2x on the left. And dividing by 2 gives us x is 16. The oh, I was going to stop there. My bad. So, yeah, stopping there, and we'll start video 5 in a couple minutes.